All right, let's pull back the curtain on something we use every single day, maybe every single minute, the internet. But how does it actually work? What's really going on under the hood? Today, we're going to build a really simple but super powerful way to think about it, a kind of mental map for how our entire digital world is put together. So, let's dive in.
I mean, just stop and think about that for a second. It's kind of mind-blowing, right? You tap a link, and a video that's sitting on a server halfway across the planet just appears on your phone. In the blink of an eye. It honestly feels like magic. But it's not magic, it's just one of the most incredible feats of engineering ever. So how on earth does it pull that off?
Okay, so the best way to get our heads around this is to stop thinking about some fuzzy, vague cloud. A much better way to picture the internet is as a gigantic, physical, global transportation system. Yeah, just like one for moving goods, but this one is designed to move information. It has buildings, it has highways, intersections, the whole shebang.
So, just like any transportation system, every single journey has to have a starting point and a destination. And for the internet, all of that action, all of that communication, it begins and it ends at what we call the edge of the network. So what exactly lives out there on the edge?
The things on the edge are called end systems. And these are all the devices we know and love, our laptops, our phones, but they're also the massive servers and data centers that hold all the websites and videos. In our analogy, these end systems are the buildings. They're the houses, the offices, the warehouses, the movie theaters. They're where information is created and where it's ultimately consumed.
Now, you're also going to hear these end systems called hosts. And that name makes perfect sense because they literally host the applications that we use. Your phone hosts the Instagram app. A Netflix server hosts the movie you're about to stream. So hosts and systems, they're the buildings at the edge where all the interesting stuff happens.
And what's just wild is how much the world of hosts has exploded. I mean, it's not just about computers and phones anymore, not by a long shot. We're talking smart TVs, game consoles, your doorbell, your thermostat, your watch, even your fridge. This is that Internet of Things you hear about, and it basically means that billions and billions of new buildings are popping up and getting connected to this global network all the time.
Okay, so we've got all our buildings, our hosts, out there on the edge. But what's the point of buildings if there are no roads connecting them? Well, for that, we have to look inside the Internet's core. This is the nuts and bolts, the infrastructure that acts as our digital highway system.
So the core is basically this huge, sprawling mesh of two main things. First, you've got communication links. Think of these as the actual roads and highways. They're the fiber optic cables running under the ocean, copper wires, radio signals, you name it. And second, you have packet switches, which most of us just call routers. These are the critical intersections that direct all the traffic.
So how does your data actually drive on these digital highways? Well, it uses this absolutely brilliant method called packet switching. See, instead of trying to send a huge movie file in one giant chunk, your computer first chops it up into thousands of tiny little pieces called packets. Then each packet gets sent out into the network, kind of like a single truck in a massive convoy. They might even take different routes. But miraculously, they all get to the destination and are put back together in the exact right order.
And this right here, this quote just ties our whole analogy together perfectly, doesn't it? The packets are the trucks. The links are the highways. The routers are the intersections. And the end systems, our devices, are the buildings. Once you see it like this map of the internet, it all starts to click into place.
All right, we've got the buildings and we've got the highways. But, what are the rules of engagement? How do these hosts actually talk to each other? Well, it turns out there are two main ways this conversation happens.
The two big models are client-server and peer-to-peer, or P2P. The client-server model is like ordering from a huge central warehouse. You have one big, always-on server that has all the stuff, and a bunch of clients ask for things from it. That's how most of the web you use every day works. Then there's peer-to-peer. This is more like a neighborhood flea market or a swap meet. There's no central warehouse. Instead, everybody just talks directly to everybody else, sharing and trading information.
Now, in any of these internet conversations, the roles are super clear. The client is always the one who starts things off. It's the initiator. So when you type a website into your browser and hit enter, your web browser is being the client. It's sending out the very first message, kind of like knocking on a door and saying, "Hey, can I see what's inside?"
And on the other side, you have the server. And just like its name suggests, it serves. It's the process that's always on, just waiting. It's listening for someone to contact it. So when the web server for that website gets the knock from your browser, it responds. It serves up the web page data. It's this fundamental dance,
Client asks, server responds.
But this is where peer-to-peer totally flips the script. In a P2P network like, say, BitTorrent for file sharing, your computer gets to be both at the exact same time. It's a client when it asks other people for little pieces of a file it wants, but it's also a server when it gives the pieces it already has to other people who are asking. Everybody is both requesting and providing all at once. Pretty cool, right?
So when you put all these pieces together, the edge with all the hosts, the core with all the highways and intersections, and these different ways of communicating, you end up with a system that is just unbelievably tough and scalable. Seriously, the genius of this design is the entire reason it's been able to grow from just a few computers to the planet-spanning network it is today.
So let's wrap this up with the big takeaways. First, you've got this beautiful division of labor, a relatively simple edge where we are connected to a super complex core that does all the heavy lifting. Second, that whole packet switching idea makes the network incredibly efficient and hard to break. Third, the architecture is flexible enough to handle totally different ways of talking, from centralized client-server to decentralized P2P. And finally, and maybe most importantly, because it's a network of networks, there's no single off switch, no one point of failure, which is the secret sauce to its amazing reliability.
And that leaves us with one last really interesting thing to think about. See, today you have these mega companies, think Google, Amazon, Netflix, building out their own massive private global networks. They're basically building their own private superhighways to get their content to you faster. And this brings up a fascinating question. Is the clear line we've drawn between the buildings on the edge and the highways in the core starting to get a little blurry? Are they creating a new kind of internet? It's definitely something to chew on the next time a movie starts instantly on your screen. Thanks so much for joining me.